Well, we've gone through the hard part of finding the surface area of our prisms, cylinders, pyramids, and cones. So let's get a little bit easier working with the volume, right? The amount of space that an object fills up. Well, it's a lot easier to deal with here. To find the volume of a prism or a cylinder, all we have to do is find the area of the base and take it times the height. So make sure that big B, the capital B, stands for area of the base. So for example, if I would look over here at my rectangular prism, well, you got to determine which part do you want as the base. What's your base shape here? Well, it's a rectangle. So I got to decide, do I want to use the piece that's on the bottom as my base? Or do I want to use the piece at the front as my base? Okay, you have to make that decision. And with a rectangular prism, you can choose any one. So let's say I choose this front base as its base. Well, just like we talked about, it's the area of the base times the height. So in this case, the area of the base is a rectangle. So we would take length times width of that base and then times the height of the prism. So here I would take the length times the width and then times the height of that prism to fill it up. When you get to a triangular prism, like for the second one here, well, now my base shape, just because this rectangle is on the bottom doesn't mean it's the base. Right? It's got to have an opposite shape that's the congruent and parallel. So for example, right here, this front triangle is the base because it has a triangle in the back that's the exact same. So that would mean if I would find the volume of this guy, area of the base times the height, the base is now a triangle. And how do I find the area of a triangle? Well, 1/2 base times height. So I'd have to take 1/2 base times height of the triangle and then times the height of the prism. That's the only difference. So it'd have to be 1/2 base times the height of the triangle and then times the height of the prism. Okay, even for like a pentagonal prism, well, the pentagon is my base shape. Well, how do I find the area of a pentagon? 1/2 times apothem times perimeter. So if I wanted to find the volume of this entire prism, I would have to take the area of the base, which is 1/2, times apothem times perimeter, and then times the height of that prism. Okay, so it just depends on what your base shape is. And obviously for a cylinder, it's a circle, and we'll get to that. So just a couple examples here. Find the volume of the prism. So I'm just going to go ahead and write down volume equals area of the base times the height. And if I take a look, my base shape here is a triangle. So for big B, I'm going to use 1/2 base times height. I like to just put that in there and then times the height of the prism, which in this case it looks like is 25. And then we just plug in the information that we know. So area of the base is 1/2 times the base of the triangle, which is 10, times the height of the triangle, which is 12. So this gives me the area of the base, and I'll find that quick. It's really 5 times 12, which is 60. And then times the height of the prism, which is 25. And so times 25. And for our total volume, we end up with 1,500 centimeters. And it's volume now. So volume is 3-dimensional, so cubed, the amount of space. Okay, so you just got to determine what's the base shape. Well, and just like I said a second ago, if you have a cylinder, well, what's our base shape now? It's a circle. So here's my volume formula, area of the base times the height. Fill it up. Well, my base here is a circle. So what am I going to use for the area of the base? Pi r squared for the area of the base, and then times the height of the cylinder. And we just plug in the information that we know. So pi r squared, so pi times radius, well, 1.8. So 1.8 squared times the height of the prism, which in this case is actually 1.8 as well. So I can either type this all into my calculator at once or make sure that I do the exponents first to follow my order of operations. So I'll just type it all in. I'm going to take pi times 1.8 squared times 1.8. It's really 1.8 cubed, huh? And that gives us 18.3 centimeters cubed. Okay, so just same type of thing for your cylinder. Right? And it might not always be this easy. They might give you some different information to use a trig ratio or Pythagorean theorem to find the missing side. But then it's just area of the base times the height for that volume. What happens if it is oblique, right? It's kind of slanted here. How do I find the volume of an oblique cylinder? Well, if I think about it, if I just like cut out a circle somewhere in the middle of this cylinder, like if I just slice it right in half, that area of the circle is the exact same as the area of the circle on the bottom, right? So if I found the area of the circle on the bottom, I should be able to still just take it times the height of that oblique cylinder, and it should be the same volume, because no matter where I cut a piece out, it's the exact same area as the base. And so that area is just going up that amount of feet in this case. So don't use the slant height. We're still using the vertical height here, even though it is slanted. So same type of thing. Area of the base times the height. And in this case, the area of the base is pi r squared. And then times the height of the prism. So plug in our information. So pi times the radius, which is 15. So 15 squared times the height of 25, which we just talked about. And then we just type it into our calculator. So pi times 15 squared times 25. And we end up with 17,000, my fault. 17,671.5 feet cubed. Because we are in volume now. There you go. So nothing really changes with the oblique. Still using the vertical height. And that's about all there is to it. So just area of the base times the height.